Solving systems by graphing. A system of linear equations is comprised of two or more linear equations. The solution of the system will be the values of the variables which make all the equations true. So here's an example of a linear equation. We have y equals 2x minus 4. And the graph of the line that represents the solutions to the above equation is shown here. It represents all the points whose x and y values make the above equation y equals 2x minus 4 true. The line is easy to find from the equation since the equation is in slope-intercept form. If you recall, slope-intercept form is y equals mx plus b, so we can automatically identify our slope is 2 and our y-intercept is 0, negative 4. Now here's another linear equation. We have y equals negative x plus 2. Similarly, this graph is of the line that represents the solutions to this equation. It represents all the points whose x and y values make the above equation true. So now we have the two linear equations together. We have a system. So here are the lines that represent the solutions to both these equations. Each line shows the infinite set of solutions for each separate equation. Now, what must be true now about the point at which they cross? Let's discuss. We know that the point is on both lines. So think about what that means for the equation. Think about what that means for that specific point where they cross. At the point they cross, both equations must be true since that point is on both lines. So they appear to cross at 2, 0. So let's check that that is a solution to both equations. To do that, we'll substitute in x equals 2 and y equals 0 into both equations and see if that produces a true statement. So for y equals 2x minus 4, if we substitute in that y equals 0 and x equals 2, that will give us 0 equals 2 times 2 minus 4, which is 2 times 2 is 4, so 4 minus 4 is 0. 0 equals 0, so that point 2, 0 is true for the green linear equation. Now let's substitute in y equals 0 and x equals 2 for that orange equation, that line. So we're substituting in y equals 0 and x equals 2. So 0 equals negative 2 plus 2. Negative 2 plus 2 simplifies to 0, so that produces a true statement as well. So substituting in x equals 2 and y equals 0, that point where the two lines are crossing makes both of the equations of those lines true. So that means if we now have a system of y equals 2x minus 4 and y equals negative x plus 2, the solution to the system is that point where they cross 0, 2, because it made both of the equations true when you substituted in those values. Now, not all systems have solutions, and there are some systems that have an infinite number of solutions. Let's see how to figure out whether there are solutions to systems, how many there would be, and what they would be. When graphing two lines, there are three possibilities when determining the number of solutions. There's the possibility that the two lines will meet in one point, and that would be the point of intersection. That was in the example we've seen. But then there's the possibility that the two lines will never meet, that they are parallel lines. And then there's the third possibility that the two lines meet at all of their points, and they're in fact the same line. They're right on top of each other. So due to that fact, due to the three possibilities for when graphing two lines, systems of equations can either have one solution if the lines meet at one point, if they cross, if they intersect, 0 or no solutions if they never meet, which is when they're parallel, or there's an infinite number of solutions if they are the same line. So here's that example from before that we saw, and this would be type number 1. Again, this is when the system has one solution. The two lines intersect in exactly one place, so the solution is the point at which they intersect. And if we were looking at the actual equations of the lines, the slopes of the line must be different because that is causing them to cross. They would never cross if they had the same slope. So this is the example we started with, and as we confirmed, there is one solution to this system of equations. It was 2, 0. It's where the lines of those two equations cross. But here now we have our second type where there's no solution. As you can see from the graphed lines, these lines never meet. There is no solution true for both lines. The lines are parallel. They must have the same slope since they are parallel as well. We would be able to see that by looking at the equations. But they must have different y-intercepts, or then they would be the same line. So you have to be careful. Start with the slope, but then you also have to look at those y-intercepts. So here's an example where we can see the equations of these two lines. We have y equals 2x minus 4 and y equals 2x plus 2. And both are written in slope-intercept form, that y equals mx plus b, so it's really easy to compare the slopes and the y-intercepts. We can see the slopes for both lines is 2 from that coefficient of x, which means the lines are parallel. We also can see that the y-intercepts are different with -4 and +2, so the lines are not the same. They're never going to cross. They have the same slope, but different y-intercepts. They are parallel. And therefore, the system of those two lines has no solution. Now, here is the third type where a system would have infinitely many solutions. This is where the lines overlap at all points. They are different equations for the same lines, so you often don't know they're the same line at first until you would write them in a different form. But they must have the same slope, and they must have the same intercepts as well, since all of their points are the same. So here is an example where we can see the equations. We have y equals 2x plus 2 and y equals 2x plus 2. Both of these equations are written in slope-intercept form. They're in that y equals mx plus b because it makes it easier to compare the slopes and the y-intercept. We can see the slope for both lines is 2, again from that coefficient of x. And we also can see that the y-intercepts are 2 from the +2, the constant. So the lines are the same. They overlap everywhere. Now, it's not always that easy. You won't always have your lines in slope-intercept form. In slope-intercept form, the fact that these are the same line is obvious. These are the same equation, y equals 2x plus 2, just literally in two different colors. But if the equations were written as below, if it was 4y minus 8x equals 8, and -10x equals -5y plus 10, it would be less obvious. So that leads us into the conclusion that when looking at a system, it's a good idea to always put the equations in slope-intercept form because they're easier to read, they're easier to graph, and they're easier to compare. And then you can identify the type of solutions that that system would have very easily. When looking for the number of solutions to a system, there then becomes a certain step that you take. You would first put the equations into slope-intercept form by solving for y, and then you can decide on the number of solutions. After that, the solutions can actually be found in 3 different ways. But how can you quickly decide that number of solutions a system has again? Now, again, it's important for it to be in slope-intercept form, but why? What really in slope-intercept form quickly identifies a solution will have one, or a system will have one solution? What about slope-intercept form would let you quickly identify if the system has no solution or versus infinitely many? Think about slope-intercept form itself. You have y equals mx plus b. What are the important characteristics we're looking for? What is going to make these 3 different possibilities stand out? Well, when you have your system written with both equations in slope-intercept form, there will be one solution if the 2 equations have different slopes. So if the value of m is different for both lines, and that means that there are 2 different lines. For no solution, you would again be looking at m to see if they now have the same slope, but then you would want to see if they have different y-intercepts, so that would be your b value, and then you can identify that you're looking at parallel lines. They're never going to cross. And then you can see if a system has infinitely many solutions if you look and see they have the same slope, the m value, but then they have the same y-intercept, the same b value, and that they're the same line. So to see if there's one solution, just see if they have different slopes. Automatically, one solution. We don't even care about the y-intercept. The y-intercept could be the same, it could be different, but it doesn't matter because they just have different slopes. Versus no solution is the same slope and different y-intercepts. An infinitely many solution is the same slope, and the same y-intercept, it's the same line. So here's where we can see that process. It says, let's solve the system of equations. We have the equation y equals negative 4x plus 5, and the equation 8x plus 2y equals 12. So the equation on the left is in slope-intercept form. It's in the form y equals mx plus b. The variable y is isolated. So do you see that the slope is negative 4 since m is negative 4, and the y-intercept is plus 5 since b is equal to 5. But the equation on the right is not in slope-intercept form, so we can't see its slope or y-intercept right away. This equation does not have the variable y solved for. It's not isolated on one side of the equal sign. So we can't tell yet how many solutions will satisfy both equations. We don't know how many solutions there would be to the system yet because it's that second equation. So what we can do is, well, let's solve the second equation for y. Let's find that slope and y-intercept. If we have the equation 8x plus 2y equals 12, so again, the variable y is being multiplied by 2 and added with 8x. So first we'll subtract 8x from both sides, leaving us with 2y equals negative 8x plus 12. We'll then divide both sides by 2 to undo multiplying by 2, which will give us just y equals negative 4x plus 6. Now this is in slope-intercept form. Now we have the y variable isolated, and we can see that the slope m equals negative 4, and the y-intercept is going to be 6 since b equals 6. Now going back, we can compare. We had our original equations, y equals negative 4x plus 5, and 8x plus 2y equals 12. Now we have both of our equations in slope-intercept form. The first equation is the same, but the second equation, 8x plus 2y equals 12, is now written as y equals negative 4x plus 6. So from that, we can now easily identify the slopes and the y-intercept. We have a slope of negative 4 for the first equation and a slope of negative 4 for the second equation. Then we have a y-intercept of 5 for the first equation and a y-intercept of 6 for the second equation. So the slopes are the same, but the y-intercepts are different. So think back, how many solutions would there be to this system? So you should think when the slopes are the same and the y-intercepts are different, the lines are parallel. There are no solution to this system. These two lines will never cross. Let's do one more example. Let's solve this system of equations. So we have the system of y equals negative 2x plus 7 and 8x plus 2y equals 4. So the equation on the left is in slope-intercept form. It has the y isolated. So we can see that the slope is negative 2 from m equals negative 2. And the y-intercept is plus 7 from the fact that b equals 7. But the equation on the right is not in slope-intercept form. It is not solved for y, so let's do that now. So 8x plus 2y equals 4. First, we'll subtract 8x from both sides since the variable y is being multiplied by 2 and added by 8x. So that will give us 2y equals negative 8x plus 4. And then we'll divide both sides by 2, which will give us y equals negative 4x plus 2. So this is now, the equation is written in slope-intercept form. So we can easily see now the slope of negative 4 and the y-intercept of 2. So now going back and comparing, we had the original equations that we then wrote in slope-intercept form. We now have y equals negative 2x plus 7 and y equals negative 4x plus 2. We then can identify the slopes and the y-intercepts. We can see that we have a slope of negative 2 for the first equation and a slope of negative 4 for the second equation. Automatically, we see that the slopes are different, so we don't even have to really reference the y-intercept. We automatically should be able to tell how many solutions there are. Think, how many solutions are there when you have different slope or different lines with different slopes? You should think that there's going to be exactly one solution. When the slopes are different, these are two different lines that are going to cross and intersect at one point, so there is one solution. So keep in mind, we haven't actually solved for the solutions, but when your lines are written in slope-intercept form, you can compare them easily and see if there will be one solution no solution or infinitely many solutions, you can tell how many there will be, which is going to be the first step in really finding what that solution is if it was one solution. So you can identify and make that call.